Now I'm going to introduce my amazing students. So we have Ryan Salinas, Asher Vigil, Aurelia Chavez, and Ariana Zarzo.
So thank you for coming today. My name is Asher Vigil. I was one of the students that participated in the Projecting Particles workshop. This is my second time participating in the workshop. The first time I was a student, this time I'm a team lead, along with Aurelia Chavez and Agnes Chavez. So what this project is taking what we've learned from the science of particle physics and doing it and communicating it through art. So why particle physics?
And so what we do is we use physics to create art, projections, and we just incorporate science into art as a medium of understanding the universe. And so here's a diagram of the history of the universe. It starts off from the Big Bang, and then it shows all the different particles that have come out, discovered, and have created life, and all these different types of galaxies and stars, and the different types of particles that communicate what the history of the universe is all about. And so this is the workshop that we participated in. We have pictures of Michael Wadness, who's a teacher in Massachusetts. He came and taught us about the Large Hadron Collider and how it works, and he did different projects with us to help us understand all the different concepts in physics. And also we had Seidel, a UNM physicist who works at ATLAS, the Large Hadron Collider in Geneva, Switzerland. And she taught us about how different concepts relate to physics and how they help incorporate what we learn with art. And so we did different hands-on activities. We learned about how the detector works, and we did workshops on the actual collider. And so here we have a picture of the Large Hadron Collider. Aurelia will describe it.
So the Large Hadron Collider is in Geneva, Switzerland, near the border.
No, it's
France. By France. And it's 27 kilometers in circumference and 50 meters below ground. And the reason it's so far below ground is so that the radiation from the sun and outer space doesn't interfere with what's going on
underground
in the project.
Okay, so now we have an actual detailed picture of what happens inside the collider. So basically they have, so here's a picture of the actual collider. So these are actually huge tubes that go around in a circular pattern, and that's another small tube, which is the old collider. And so what they do is they beam particles at almost the speed of light, and they try to have collisions that produce energy and see what kind of deposits of particles they have left from them. And so here's an actual picture of a collision. And so we have these different lines that are actually different particles. Like the short white lines are pictures of electrons, and the blue lines that we see coming out are muons. And then the green ones, you can see that those are photons. And so you get to see through this small collider picture the different particles that come out to discover what kind of collisions help create the particles.
So Sally explained that the total energy produced from a collision is equal to an amount of a flea doing a push-up. And that just made me so emotional because on media it's portrayed like a big explosion or like the world ending. And then just to know that it's like a very small amount of energy produced is very
So we just have a lot of misconceptions about how much energy is actually produced from the particles colliding into one another.
This picture just demonstrates UNM physicians and students working on a piece from the ATLAS detector. So
there are people here in New Mexico who actually worked as physicists on this project to create the whole big scheme picture of the detector. Okay, So here's what we actually did in the workshop, where we analyzed and compared data from the particles from the slides that CERN gave us to analyze. And so what we learned is the different spikes. So we have a graph here. These describe the different spikes in energy concentrations inside of the particle detector, where you could actually see where there might be a new particle that could be discovered, like the Higgs boson. And so basically we just did that workshop, and we got to see the different levels in which the detector works.
And so, why did we use art? The medium that we used with the program on the iPads gave us a great perspective to what we were trying to portray, with the images we see from the collider and what we think particles would look like crashing, and how we would see it. So what we did was we used this program on Tactile once again, and we created storyboards, which you can see on the bottom right-hand side.
So this is a skin tone. This is what I started out with. So I just picked like a human skin tone, and I went from it to like the pupil, like the white part of your eye. Then over that I went over with like a black liner. And over that I went over it with what does that say?
You filled in the
pupils.
irises and pupils. Yeah.
Then I went over shading and eyelashes. Then I went to the eye and it can move. Then I zoomed
gave
into
it
the
more
eye.
detail.
Then I went into the eye, and then I could see like atoms and neurons and electrons.
So it gave us the ability to get all our ideas out on one paper, decide how we're going to strategically put out our art piece.
So learning how to use Tactile was an interesting process. You would get to learn how to move the particles and how to color them. And there's different colors and how to use transparency. Like this picture up there, that was probably my favorite part about learning how to use Tactile, is that you get to mess around and you finally figure out what you wanted to draw and how to incorporate the science into it. And then you would go from there and you storyboard and come up with different ideas, and then you have a set idea.
So this was the images of some of the art that we did at the lighting of the dew. We did it on one of the walls outside of the museum. It was really interesting to do, to project our art on these big walls, outside, and see the colors and how they collide with all the different vegetation and different colors of the walls and the dimension with the corners of the walls. And it was very interesting to give another view to our art. And so this is an image of the team from the first projecting particles event.
So we went to TISA, Taos Integrated School of the Arts, and we were demonstrating children how we were using physics and art and putting that together. And we just shared what we learned, and it was a really good experience.
So here we have a picture of me talking to all the students at TISA and explaining to them what we did in these workshops and how our art incorporates into the tactile mediums that we're using to create art. And so they were brilliant. The students really knew what they were talking about, and they would ask questions that I had no idea how to answer because I'm a high school student, not a physicist. And so I tried to explain to them in the best of my ability what it is that I learned, so that I could teach them exactly what physics is and how to incorporate it into their own art. And so we did different workshops, and we worked with Tactile.
So we had to find a place to project our art and figure out how it was going to look. So first we're going to find somewhere outside, but the weather wasn't permitting. And we looked around the school and we found that the little theater at the high school was a great place to project our art. And it's a very dark room, and it has big walls and big spaces for us to project our art.
So here are some actual visuals of what we did and what our projects were using what's it called? Tactile.
So what me and Aurelia tried to portray with these images was seeing the particles going through the collider, coming back and forth, hitting each other, and that's how we express it.
Cool. And now we have mine and Ariana's projection. Oh, oopsies. Okay, so here's a picture, and then here's the actual video. So me and Ariana went a bit of a more chaotic route than what Asher and Aurelia did. A lot of it is just describing how particles, all the different dots and all the different pieces work together, and it's kind of like this chaotic mess. And so I guess that's what our visual really tried to represent in the form of art through tactile. Do you want to say anything on that? No?
On behalf of the team, we'd like to thank Agnes for giving us this opportunity to participate in the workshop.